Okay, students. Okay, let me just select the pointer. Okay. Okay, this is fine now. So, in today's lecture, we are going to discuss about the registers. I am doing it with the help of a book because this book has they have described it in a very good way. Okay, I have basically the notes as well, but obviously from the book you will understand it more better. Okay, so that's why I'm doing it from the book. But if you really want notes as well, then I will just definitely post the notes as well. Okay, so this is the registers. First of all, I will explain what do you mean by the word registers. Okay, so you all know what are flip-flops, right? So registers is basically, as it is written here, a register, unlike a counter, has no specified sequence of states. A register is a digital circuit with two basic functions: data storage and data movement. Okay, so here single flip-flop can store one bit of a binary numbers, right? So you all know, you have studied flip-flop. What was the function of the flip-flop? Flip-flop was used to store one bit of information, right? Now what are registers? Registers is basically the combination, the series of the flip-flops, you can say, which is used to store and shift binary data. And this shift can happen as serially, parallelly, as we will discuss in the next slide. Okay, the storage capacity of a register is the total number of bits it can store. Okay, now shift registers, as its name indicates, shift means they will shift the data. Okay, as a flip-flop can store only one bit of data, either 0 or 1, it is referred to as a single bit register. Okay, but when more bits of data are to be stored, a number of flip-flops are used. And a register, what is a register? It is a set of flip-flops used to store binary data. So it is written here, basically registers are a set of flip-flops which is used to store binary data. Okay, what is the need of a register? Obviously, I told you, temporary storage and the shifting capability. So if you want to store your data, then you need a register, and if you want to shift your data, you need a register. How we shift the data, we will discuss it in the next slide. Okay, now there is a concept of storing the data in a register. We will see in the next slide. You can see here, it is a flip-flop. I'm not reading it for you now. It is a D flip-flop. You can use any flip-flop because the main function of flip-flop is just to store the binary information. So if there is a clock pulse 1, if we have given the input 1, that means this 1 is stored in this flip-flop. And what will be the output we will getting? We will be getting the output 1. Okay, so if we remove the clock pulse, still the data is stored in it. The data will not be vanished, right? And so it will wait for the next input to come. You understand this? So this is basically the concept of the flip-flop. We will definitely give the negative edge triggered flip-flop, and this is the 0. We have stored the 0, so this is the 0. Okay. Now classification of shift registers. It is very important. You can see classifications based on the direction of data movement. Shift left register. What is shift left register means? If we shift the data on the left hand side, this is called the shift left register. Shift right register means if we shift the data to the right hand side. Okay, bidirectional, as its name indicates, that means it can shift to the left, it can shift to the right. Okay, classifications based on the mode of input and output. Very important, you need to remember all the classifications. So the first one is serial in, serial out shift register, SISO. S for serial in, serial out. Next is serial in, parallel out shift register, that is SIPO. Next is parallel in, serial out shift register, that is PISO. Parallel in, parallel out shift registers, PIPO. And universal shift register. Universal shift register means it will do the serial in, serial out, it will do the serial in, parallel out, it will do the parallel in, serial out, and parallel in, parallel out. Everything it will do with the help of the universal shift register. Okay, this is the buffer register. Buffer register is basically is the simplest of register. It simply stores the binary word. Figure 5.2 shows a 4-bit buffer register. Okay, so it is basically a simple type. Buffer means, suppose if we want to load any data on the flip flop, like if we want to load 1 1 1 1. Okay, so it is written here q3 q2 q1 q0 x3 x2 x1 x0. So what is x3 x2 x1 x0? It These are the inputs, and q3 q2 q1 q0 are the outputs. Okay, so whatever is stored, the output is there. Whatever is stored, the output is there. Okay, and when the data will be stored, when the clock pulse will be high. So if we are doing the clock pulse high, that means whatever be the input, the input will go to the output. Okay, so this is the simplest type of the register, which is known as the buffer register. Okay, move to the next slide. This is controlled buffer register. Obviously we will do it when we will finish all the serial in, serial out, serial in, parallel out, all those registers. We will cover control buffer register after that. Okay, it will be easy to understand when you will understand those type of registers, so just leave it for now. Now this is the most important thing: serial in, serial out shift register. So these are of two types: shift right and shift left. Okay, so it is serial in, that means we are doing the data like that, serial in, and the data is going serially out. So this is going right side, so that means it is shifting the data to the right, so it is shift right. Okay, now here it is serial in, serial out, but shift left, that means we are giving the data from this side and it is going out from that side. So this is shift left and this is shift right. Okay, now we'll do it in detail in the next slide. Yes, this is shift right register, very important. Just try to understand the concept. Okay, so shift right means this is D flip flop I have used. So these are the flip flops A, B, C and D. The data is D3, D2, D1 and D0. And this is D in, the data in, this is D out, and this is the clock pulse. Okay, so for doing its operation, the clock pulse must be high. Okay, so here they have taken an example 1101. Okay, that means we have to store this data 1101. That means q3, here it must be 1, it must be 1, it must be 0, it must be 1. Okay, don't be confused with the sequence, please. 1101. Okay, now look here on this one. First of all, initially register is cleared by using the clear pin. First of all, we will do the clear pin, so the register will be cleared. Okay, that means there is no data. All the flip flops have 0 0 0 and 0. Okay, perfect. So this is flip flop 1. It is mentioned here: flip flop 1, flip flop 2, flip flop 3 and flip flop 4. Don't be confused D0 D1. So you will see, means you will be confused like it will be flip flop 1. No, the flip flop 1 is this one, flip flop 2 is this one, flip flop 3 is this one and flip flop 4 is this one, because we are shifting it right. So we will give the data here, the input data here. Okay, so the input data is 1101. Here they have taken an example 1101. We can take any example like 1011, 1111, 1101, any example. Okay, so if there are 4 bits, that means we are using 4 flip flops. If it is 5 bits, then we are using 5 flip flops. Okay, now come here. When the data D3, D2, D1, D0 equals to 1101 is applied serially, D in equals to D0 equals to 1. That means what we will do, we will start from here, this bit. This bit will first go here. You understand this? Because if we do this bit here, it will not store this data 1101 because the data will be shifted like this. Okay, so we will start from this bit. Remember, we will start from this bit, the rightmost bit. So we will enter this bit 1 here. So at the first clock pulse, at the end of the first clock pulse, what will happen? We are giving 1. So this flip flop will have the value 1, and rest of the flip-flops are 0 because initially the register was clear. So the output after first clock pulse will be 1 0 0 0. Understand this? This is the first state. In the next state, what we will do, we will enter this 0. You understand? We will enter this 0 here. So what will happen, this one will move to here, and this 0 will go to D3. Okay, and rest flip-flops will be 0 and 0. So the data will be 0 1 0 0. Understand this? This will be written in the next slide. I will show you, but just try to understand what I am saying. So the next one, the next clock pulse, we will enter this one. This one will be entered here. So this one will be entered here. That means this one will move here, this 0 will move here, and this one will be here, and this is 0. So the data will be 1 0 1 0. Understand this? And at the last one, this one, this one will be here. So this one, all the data will shift right, and the data finally data stored will be 1 1 0 1. Okay, try to do it with the pen and paper in your notebook. I'll explain it in the next slide. It will be more clear to you. See, look here. So at the end of the second clock pulse, the data is 0 1 0 0. Okay. At the end of the third clock pulse, the data will be 1 0 1 0. Okay. And at the end of the fourth clock pulse, the data will be 1 1 0 1. So basically all the bits will be stored 1 1 0 1. So remember, we will start giving the data from rightmost bit. You understand this? From this bit, and the data will be done like that. So the stored data will be 1 1 0 1. The content of the register after the fourth clock pulse is 1 1 0 1. So this is basically shifting right operation. Okay. Now next is shift left register. It is just exactly the same as the shift right, but what will be the difference? We will do the entry of the data from this one. You understand? And this is all just the vice versa of that one. In shift right, the flip flop 1 was that one. In shift left, the flip flop 1 is this one. Okay. In shift right, we have entered the data from this thing, but in shift left, we will enter the data from this one. You understand? So first of all, we will give this one here. So when we will give this one here, so the data input will be 1, it will be 0, it will be 0, it will be 0. You understand this? And then after that, we will enter again 1. So when we will enter again 1, this one will be shift here, this one will be here, and then it is 0, and then it is 0. Okay. Look here, it is written here. The content of the above 4 bits are shifted from one flip-flop to another flip-flop. For every clock pulse, the content of the register after first clock pulse will be 0 0 0 1. Understand this? So it will be, when we will give 1 here, so it will be 0 0 0 1. Okay. So now the next bit will be 1. So if we enter 1 here, so it will be 1, it will be 1, but this one is 0, this one is 0. So the output at clock pulse 2 will be 0 0 1 1. Okay. So you have to, when you are doing it shift left register, you have to do all the flip-flops again. You have to make this again and again, and you have to shade the flip-flop. You have to shade or the color or this flip-flop with a different color pen. Okay. Next is after the third bit and after the fourth clock pulse. So this is the data which is shifted at the left. So shift left operation. Okay. Next is serial in parallel out shift register. So as its name indicates, the data will go like this: serial in, serial right. That means the output will come parallelly like this. Okay, that means this is one type of shift register in which the data is entered in serial form and output is in parallel form. Hence, it is necessary to have all the data bits available as outputs at the same time. This type of shift register operation is same as the serial in serial out shift register. The difference between serial out and parallel out shift register is the way in which the data bits are taken out of the register. That means all the that means if the data is 1101, it's basically the data is given, so the output will be parallelly, means you can have the data output parallelly. That means at one clock pulse you are having a data at the same time if all the stored bits are available in the flip flop. Okay, so serial and parallel out we have done. I think this is the seventh slide. So yes, so for this week, this is good enough to understand the concept. Please do it with the paper and the pen. For the next week you are writing the test. Okay, and for the next week I will enter the next slide, next explanation of the notes, and you have all the notes available with you. So if you are this concept is clear to you, the shift left, shift right, serial in, parallel out, try to understand, try to read the next part of the registers. It's quite easy. Okay, let's see.